Hi, my name is Ruben Gonzalez Vera, and my research project is titled Low Energy Method of Amplitude Modulation Data Transmission for Consumer Applications. The most commonly sold electronics in the United States are smartphones, earbuds, and PCs, approximately close to 1 billion products. Now, the one thing that they all have in common is the lithium battery. You see, lithium batteries are actually supporting artisanal mining and environmental pollution. Artisanal mining is a practice using young kids starting at age 7 working at least 14 hours a day, 7 days a week inside these dark, dangerous, and damp mines that can go 40 feet straight down for a wage that can barely support themselves, much less their family. Now, this is not only a singular small mine located in Africa impacting a few families here and there, but based on a sociological analysis from the University of Manchester, estimates that there are at least 1 million kids engaged in this behavior worldwide, with a large amount being unreported due to legality concerns and owners trying to get a benefit. Since this goes unreported, some estimates believe that there's possibly twice as many kids going through this than what is actually reported. Through the environmental pollution of mining the components needed for lithium batteries, it has resulted in the release of roughly 1,000 tons of mercury released every year into the environment. Furthermore, the communities surrounding the lithium mines of Chile and the cobalt mines of Africa make for a myriad of increased health issues arising, such as lung disease, pneumonia, and lung cancer. Furthermore, there is no sign of stopping within the United States, with the amount of cell phone users increasing from 190 million in 2015 to a projected 390 million in 2030. The lithium ion industry is expected to octuple from 100 gigawatt hours to 800 gigawatt hours from 2017 to 2027. The electric car industry globally is expected to multiply by a factor of 50 from 2018 to 2030. Last but not least, the amount of wireless Bluetooth headphones is expected to double from 2015 to 2030. In order for there to be genuine change in the products that go into the market, there needs to be a balance between consumer value and environmental benefits. Once this balance is achieved and established, then value is made and products are sold. Two initial approaches arose. The first approach would be to scrap the lithium battery and create an entirely new system that would be cheaper and less environmentally harmful than lithium batteries. Due to the costs that have been taken on by other companies as a result of them trying to follow this path, the second path will be followed instead. The second approach would be to improve circuits that make data communication less energy consuming. This efficiency in circuit design will bring down the amount of batteries needed in the circuit, therefore reducing the price of the product and reducing the amount of lithium needed, therefore being a win-win. With the research at hand and how it is supposed to rival that of current consumer technology, we must establish final engineering goals for the research in order to be considered satisfactory. This would include having a sound quality of 80 decibels, this will be discussed later, create a consumer patent model ready for submission, negligible heat outputs due to the non-applicable efficiency measurements, and reduce power consumption relative to normal models. Before we continue further, we must know some simple radio physics and technology. The backbone of this research will be using tuned circuits, which is made of a capacitor and a coil. A capacitor is a quick-release battery that is used in electronics. A coil is a winding of copper wire in a circle that is connected in a circuit. When electricity passes through it, energy builds up in the coil. A tuned circuit has a coil, capacitor, and an antenna connected in the circle. When a signal from a random radio wave hits the antenna, it conducts electricity in one direction and forces a very fast cycle of energy to pass through. This rate of looping is called a frequency. Based on past research, it can be fine-tuned to a specific frequency using this equation shown and create a specialized circuit for a certain frequency. Based on the prototyping process, we have to create, test, measure, and then redesign metrics based on the engineering goals that have been discussed and the data that is collected in each prototyping stage. Sound quality is the measure of power of signal over distance. Using a digital vernier multimeter, which outputs the data as a spreadsheet and can be further calculated, what is done is measuring the electrical power over the course of 30 seconds and is then placed into the equation shown in order to gain data over the quality of the signal. Consumer quality headphones go between 80 and 100 decibels. Physical space implies how much physical space is being taken up by the prototype in relation to shipping. The results shown here is that there is very little difference between the prototypes as shown with the decibel score and efficiency. Feel free to pause here to read into the data further. Tank circuits are another name for tune circuits. The Arduino circuit is using a 315 MHz RF transmitter, and the bandpass tank circuit is another version of the tune circuit but with more resistors in order to increase sound quality and reduce feedback. The reason that there is two is because I ran into parasitic capacitance in the first version when I was using the breadboard. Based on the data that was shown here, the statistical ANOVA test shows that the null hypothesis was supported and requires further prototyping, meaning that the data is not statistically significant. Since there were only 4 prototypes that could have been created, and due to the simplicity of the circuit design, there are massive improvements that could have been made in order to rapidly increase prototyping speed and quality of the products tested. Due to how the circuits were made by hand and can have various side effects that are not considered, like accidental short circuiting. After reading further, what can be seen is that the approach of electronic simulation will make for much faster testing of circuit design. What happens during the physical prototyping and testing will be that the damaging of components between each test will make it exceedingly difficult to distinguish between which of the various components have led to the flaws within the circuit. The use of electronic circuit simulation will be based on reducing as many flaws as possible in order to speed up as many portions of prototyping as possible and move on to the next phase of product testing and development. When considering the circuits that were used, one might consider a more unconventional and new age approach. The problem with the current approach of fixing this problem of lithium usage would be that it has constrained itself to relatively old technology. The tuned circuit design has been around for over 100 years and has been taught in elementary electronics classes. It makes sense that this method would not work based on the foundational technology. Further research can involve the use of MIT's Maris Lozic, a PhD in electrical engineering, where his research has been able to send certain forms of power and data over long distances, which could be used as a backbone for future research and be used for further development and advancement of our engineering goals. This will be then further explored for further improvements in order to adjust for consumer applications. Thank you for listening to my Senior Symposium Research presentation. My name is Ruben Gonzalez Vera, and here are my references.